This question is from the 2017 exam paper. It says sum of a blue pigment azurite used by an artist in a picture painted in 1600 has changed over the years into green malachite, according to the following balanced equation. Analysis shows that the only copper-containing pigments in the painting are azurite and malachite, and that the picture now contains 3.81 grams of copper. So, what mass of pure azurite contains 3.81 grams of copper? So, for this, we want to find our relative mass of copper. So, MR of copper is 63.5. So that's of copper, and your relative mass of azurite is 344.5. So really we want to see how much, let's say percentage wise, how much of that azurite is composed of copper, and then we want to find the overall mass of the azurite that we have. In our formula for it, you see there are 3 copper atoms. So to find the relative mass, or the mass of copper in this compound completely, we have to multiply this 63.5 by 3. And that gives you a total of 190.5. So if you want to see what percentage or how much of the azurite is composed of copper, alright, it's like finding any other percentage. We want 190.5 over 344.5 and multiply it by 100 or 100 over 1. Okay, that gives you a percentage of 55.3%. Okay, so 55.3% is copper. Okay, the mass of copper that we have is 3.81 grams. So we could say that this 55.3% is equal to 3.81 grams. And really this is, it's like using percentages in maths. Okay, so if you want to find 100%, you'd want to find 1%. Okay, so you'd be dividing by 55.3 and then multiplying by 100 to get 100%, to get your full answer. When you do that, that gives you 6.89 grams. Now, instead of dividing by 55.3 and multiplying by 100, what you could do as well is just 3.81 over 0.553, and that does the exact same thing. Okay, and you get 6.89 grams. Okay, there are a few different methods that are acceptable for it. That's just the way that I have chosen. The next part of the question then asks us calculate the maximum mass of malachite that will eventually be formed from this mass of azurite. So all we're using here really is our formula again, that moles is equal to mass over your relative mass. Okay, that's the main thing that we're using in all of these questions. What we do have to try and calculate is our number of moles. In this particular question, the easiest way to do this is to use our copper that we had in part 1, or in the question even, okay, and to try and find our moles of copper. So our mass is 3.81, and our relative mass here is this 190.5, because you have Cu3. Okay, it's not just copper, it's not just one copper atom. Okay, it's three molecules of it. Okay, so it's 190.5, and that comes out to be 0.02. Okay, and that also stands for our moles of azurite. So we have 0.02 moles. So to then calculate our moles of the malachite, which we're really looking for, alright, you see that we have, I'll do it down here, but there is, there's a kind of a 2:3 ratio. Okay, so we have 0.02 moles over here. We're trying to find what this is. Alright, so we kind of really want to see, I suppose, what 1 would be. So you divide that by 2, so 1 would be 0.01. If we multiply that by 3, we'll find that we have 0.03 moles of malachite, 0.02 moles of your azurite. And then if we were to even look at the water and the carbon dioxide, then we'd have 0.01. Okay, so here we have 0.02, 0.01, 0.03, and 0.01. Okay, and then it's just using our formula. So we have moles is equal to mass over relative mass. Okay, our moles are 0.03. The mass is what we're looking for. The relative mass of malachite is 221 when you calculate it. So to find our mass, it's going to be 0.03 multiplied by 221, which gives you 6.63 grams. And that is your answer for part 2. And the last part of our question then that we have here is, what is the volume measured at STP of carbon dioxide that would be released from the painting in the formation of this mass of malachite? Okay, so we want to try and find the volume. So we have the number of moles, and if we multiply that by our figure to convert it into a volume, which is 22.4 litres, we will be able to do that. Okay, so our moles of CO2 equals 0.01. Alright, so to find the volume, we're going to do 0.01 multiplied by 22.4 litres, and that then is equal to 0.224 litres. Okay, and that is our answer for part 3.